Welcome everyone. Let's deep dive into big data visualization. Imagine the amount of data surrounding us nowadays. Sensor data, IoT devices, prices, sales, weather data, transactions, costs, all sorts of measurements, medical data. I could easily spend half an hour giving you different examples. The data generated every second, gathered and sent to us. Every day, we need to take data-driven decisions to help our businesses grow. We need to analyze our data to fully comprehend what has happened, why it has happened, and how we can potentially take actions to improve the results. We want to be able to combine different data sources in one report, aggregate it in different dimensions, filter it, apply analytics on top of it. As a private person, at our free time, we browse the internet and quickly get relevant, up-to-date content. We can easily find any kind of information, and it's loading very fast. Otherwise, we will not wait, we will just go and find another source.
Sorry for interrupting you. I think there's might be some echo.
I just tried to turn it off.
Do you have I see you have 2 users in this room. Is there another?
Yes, I switched the sound off. Is it better now?
I think so. Yeah, I think so.
Good.
Okay.
Perfect.
Yeah, sorry.
Let's
Go ahead.
continue. Yes. So as an enterprise customer, we expect to get the same B2C experience at work. It's not enough to get access to the raw data. We want to see different kind of reports, charts, forecasts on top of our data. And we are not willing to wait while it's loading. We want to get our information very fast. As a company working with customer data, we have, of course, some different challenges here. We might collect our data from a variety of devices, maybe hundreds, if not thousands of them. We own the data, and we want, of course, to make use of it because it's a huge opportunity for our company. We want to present this data to our end customers, but it's not enough. We want to use our in-house expertise and provide our customers with powerful analytics, better insights into their data, aggregate and slice the data in different ways, maybe use some machine learning models on top of it. We want also to be able to quickly respond to the new requirements and deliver new functionalities in our web application. It helps our company to build better relationships with our customers, build trust, and reduce customer churn rate. In this session, I will share our way of processing and visualizing large data sets to our end customers at Vattenfall. Vattenfall is a Swedish energy company, fully owned by Swedish state. And we are one of Europe's largest energy providers. We also have been working with customer-facing applications for many years. So during next hour, we are going to discuss our challenges and our business requirements when we work with our applications for large enterprises. I will explain how we have created our data flow, how we have designed architecture using Microsoft technologies. We will have a look how we will build our model in Azure Analysis Services, created Power BI reports on top of it, and embed them in the web application. So we will go through our authorization flow and we'll discuss security of our data. After this session, you will get an overview of one possible approach of preparing and visualizing your big data for your customers. You will get an idea how to build a modern, well-performing, and secure solution at a lower cost. And I hope you will want to experiment with it yourself and find some other benefits it can bring to your company. If you get any questions, I will be around in Slack after this session, and I will be happy to have a chat with you. My name is Irina Dragunova. I am based in Sweden. When I was small, I liked to draw. That's why you see this little princess here on the slide. Then I got my master's degree in applied mathematics and computer science. It was almost 20 years ago. And now I use my creativity to design and build complex cloud solutions. I'm also passionate about art and photography. I like to think about an application architecture as a masterpiece. You put a lot of work and efforts in it, it can be really complex. But when at the end it works seamlessly and all the pieces are in the right place and well connected to each other, you can really enjoy its harmony and balance. Currently, I am working with a solution for our enterprise customers, which use district heating. What is district heating? It's a network of several thousand kilometers of pipes transporting hot water under our feet through our towns. Vattenfall produces district heating from what would otherwise go to waste. It can be waste from forests in the form of branches, wood chips, waste timber from building sites, or surplus heat from industry or data centers. Very environmentally friendly way of heating the buildings and the loads of data. And this is a smart meter. This small device gathers all the data from our customers every hour. What it gathers: heat consumption, temperature, and flow parameters, and sends it back to Vattenfall, to our company, using the mobile network. Since many years back, our customers have been equipped with smart meters. Vattenfall is running district heating network in several cities in Sweden, and we have also customers in other countries. So we're not talking about just thousands of rows in our database, not even about hundreds of thousands. Every day, we get around 1 million of new data points. Currently, we have about 1.4 rows in our database. And this number is growing every day. And that's awesome. It's really a huge opportunity for our company. We need to extract real value out of it. We want to visualize the big data to our customers, and we want also to show our in-house expertise, provide our customers with powerful analytics, apply machine learning algorithms to do predictions, and do much more, do really cool stuff. And our customers are large enterprises. They have complex hierarchy. One parent company has multiple subsidiaries. Some parent companies can have up to hundreds of subsidiaries, and one subsidiary may have thousands of different installations. And all these installations are sending data to us. Customers need to get quick overview over all data. They want to be able to deep dive into their heat consumption because it's a huge cost for many of them. They want to get information for every single installation or aggregate the data for the whole subsidiary or even multiple subsidiaries. They want also to compare heat consumption for different installations and benchmark them against their market segment. And we gather data on hourly basis in Sweden. We have also customer data from Germany. Our German customers are equipped with different model of smart meters. They are sending data every 15 minutes to us. We call it near real-time data. Then we need to present hourly data in our web application so that our customers can easily see heat consumption trends and peaks. And we need also to visualize aggregated data on hourly, daily, monthly, and yearly basis. Our previous traditional approach was to gather all the data in our SQL database and consume the data using REST APIs. One problem was that SQL couldn't handle that massive amount of data. We could, of course, create aggregated tables in SQL, pre-aggregate all the dimensions per resolution, per installation, but it would be bad performance and also maintenance problems and very high development costs. Think about adding a new report. then you need to pre-aggregate all the data again. And customers want to see the information really fast. Response time shouldn't exceed 2-3 seconds. And what they could see sometimes was this nice screen. Sometimes when they requested data for longer time periods, for example, hourly data for a couple of years, after a couple of minutes seen on this screen, they got another one. Because our services couldn't handle that many data at once. We just got timeout. And even if we could get the data, adjusted our APIs and so on, visualizing so many data points in a browser using front-end libraries is quite problematic. We tried to solve our issue by different caching strategies. We added more and more caching on different layers. And of course, development cost of this approach is very high. Definitely issues with stability of this application. Once we had an incident in production, our application just basically stopped working. It took some time really to troubleshoot and figure out what has happened. It was a problem with one cache, badly implemented cache. And besides this, development cost of this application is high. That's why we started to think about better approach for our solution. To summarize, what are our challenges apart from a really huge data set? First of all, complex data structure. The need to present our data on hourly basis for longer time periods. And also, we get the data from different and slow data sources from SAP. We need to prepare this data and present it quickly. Response time shouldn't exceed 2-3 seconds. And our platform should be able to scale so that we can get more users. It's an enterprise product. It should be adapted for concurrent use so that many users can log in and get their information, access to their data simultaneously. So, what if we had just one service? So we can replace all our APIs and cachings by this, and we could quickly get the data from this service and aggregate it in any possible way. So this is not fragmented, no big need to maintain. We can replace all our caches, and this is what we need. We can also build a model over our data set and get really good performance. Scalable solution, we can easily add more data into it. What about data visualization for longer time periods? We need a tool to visualize the data and quickly embed it into our pages. Then we can fulfill our requirement. Almost 3 years ago, we started with a small pilot project. We used Microsoft Azure Analysis Services to build our model. Azure Analysis Services is a fully managed platform as a service in cloud that allows us to build massive data models. In this model, we can combine data from different sources, define metrics, applying complex queries on top of it to perform detailed data analysis. Our model data is highly compressed, cached in memory. It allows us to get the results of our calculations really fast. This model can scale up to 400 gigabytes in memory capacity. We also used Microsoft Power BI to build our reports and dashboards. Power BI is a business intelligence platform for data visualization. It's a natural visualization tool for data model in Azure Analysis Services. Then all our reports can be integrated in the web application using Power BI embedded, and our end users can easily access them. So, We started the development of our pilot project with a very small team, working at the same time with other projects. We were all busy, of course, as usual. And despite this, we were in production in about only 2 months with all the authorization mechanism, customer data, visualization, reports, and so on. And this first pilot project was about 10 times cheaper than our other pilots we worked with before in our company. And our customers really liked it. So we went further and developed our system, which is in use now into markets in production. Let's deep dive into our solution. We start with Power BI. What's this? It's a business analytics service helping us to visualize our data sets and create different reports on top of it. You can simply connect it with your model and make your dashboards in minutes. Power BI accepts data in different formats. You can use Excel, workbooks, CSV files, JSON, SQL Server database, PDF, and so on. It can be also integrated with Office 365. So this dashboard consists of several visuals, and they are connected to the same dataset. It makes your report highly interactive. I can, for example, select 1 month in one visual, and this selection will be automatically reflected in all other visuals on this page. If I have a complex data hierarchy, with only several clicks, I can drill down and see detailed information or get an overview over all my data. And we, as developers, get total control of the visuals. We can adapt them to our brand standards, use custom colors, fonts, text, tooltips, change data formats, and so on. Here is a tool. It's called Power BI Desktop. It has a drag and drop functionality. Here I connect my data set to the report and create my report. Really, you don't need to be a software engineer to create your reports. If you are an experienced Excel user, it's enough. You will learn this tool in no time. I can select many possible types of built-in charts to present my data. If built-in visuals are not enough, there is Power BI Marketplace, which contains hundreds of free and paid visuals that we can use in our reports as well. Actually, we can do much cooler stuff in Power BI than just to visualize your data. There are tools to enrich our Power BI visuals by providing better insights into your data, give comments, interpretations, so-called data-driven narratives. You can create real stories which can be generated in real time based on your data, on your selection, on your filters, and can complement the data. It can connect data from all the visuals in one report to draw conclusions. We can influence these narratives based on our selection, as I said. Power BI can also provide quick insights out of the box by analyzing the data on the fly. Even running machine learning algorithms figure out what has impacted your data jumps and peaks most. What has contributed to the gains and losses? Why your energy consumption, for example, for this month exceeded the limit? Maybe it was an outage, or you did some maintenance work, or it was very cold or windy weather, which caused higher heat costs. You can save time. You don't need to build it yourself in your application. You can just use this feature from Power BI. What else? Natural language analysis. Q&A feature. You can ask questions about your data set. What was an average consumption for week 42? And Power BI will give the right sort of visualization based on some built-in visualization rules. We can ask some really complex questions, specify filters, and Power BI will iterate through the data and give you the results back very quick. We can train the model, translate the speech into queries. It can process really large data volumes. So, Power BI is a really cool and very powerful tool which you can use to enrich your web application. But sometimes you may want to use some other tools to visualize your data. Maybe you have something already working, you have built something and you don't want to rebuild it. It's an overkill to use Power BI. You want to use some simple front-end library for some reports. It's perfectly fine. Everything depends on your use case. Power BI reports are very customizable, can be easily combined with other front-end libraries in one application, even in one view, on one page. Here on this slide, on the left hand, you can see some Power BI reports. On the right side, these reports have been built with other front-end tool. You see they look very similar. It can be seamlessly integrated into one web application. So, Power BI is embedded in the application with all the features, functionalities, including drill, tooltips, toggles, and so on. So this is how our application looks like today. This page has both web components and Power BI embedded report combined in one view. It's up to you, how do you want to build it? In our first pilot project, we started with one big Power BI report per page, covering basically everything: navigation, filtering, data picker, date selection, and so on. Then we realized that we want to manage a state across the whole application. We want to be able to keep company selection, date range, date picker selection, and some other filters across all the pages when user navigates through our web application. Then it's better to move from Power BI to the web interface, everything that can be moved, that you want to move, and use Power BI. For that, Power BI is best for visualizing big data sets. So this is Power BI report. And this is company and premise filtering. When you select some company or some installation, this change will be reflected in the Power BI. We will go through this process a bit later. This is time resolution selection. You can select hourly, daily, monthly, yearly resolution here. Here is a date picker, and all this can be used for filtering your data set in the report, in Power BI report. And Power BI has also export API, allowing us to export our data set to CSV file based on our filters, applied filters for this page. So let's look into our technical realization. This is how the architecture of our application looks like today. This is really a very simplified diagram, but it gives you a good overview. Let's discuss this in some details. So first of all, we have SAP, where we take our historical data, such as information about installations, addresses, contract information, invoices, historical heat consumption flow, and so on. This data comes every night with batch load, first to our data lake, where we aggregate and clean the data, apply some necessary transformations using Azure Databricks. Databricks is a data engineering tool which is used for parallel processing and transforming really massive quantities of data. It's a powerful tool which gives us a lot of possibilities for data transformation. Then we save all the data in our central SQL database, and we use Data Factory to orchestrate all this process of loading, processing, and transforming the data. Data Factory also helps us to publish our transformed data to our data store SQL database. Let's take a quick look into our data transformation process. In our organization, we follow modern data warehousing concept. We use centralized Azure data lake storage for the whole company. Our company is really big. Here we store both structured and unstructured data from different sources as it is. This storage is cheap, and we can share the data across all the projects. Everyone in our company can use it to build a project. Then we use Azure Data Factory service to orchestrate the ETL process, extract, transform, load in the data lake, and further to SQL database. We load all the data file by file, first to staging. These files come from different places and often contain really small amounts of data. For example, electrical consumption data for one company, one installation for 1 month. And we need to aggregate this data together, clean it, and then we save the data in RAW. Then we perform some necessary transformations, aggregations with the raw data. We apply some business logic on top of it and save the result in BTL, business transformation layer. And for all data transformations, we use Azure Databricks. Databricks can work with several different languages, for example, Python, Scala, Spark SQL. And we try to use as much standard as possible. It makes it easier for us to maintain this solution and then to find people with the skills to work with this solution. Now we continue with traditional BI approach. After processing the data in the business transformation layer in data lake, we transport all the data to our SQL database. And why do we need SQL here? We use this just as a temporary storage of data, because there is no mechanism for now to transport data directly from data lake to Azure Analysis Services. But we are looking for a new approach and working on this. Then we built Star Schema in Azure Analysis Services. Star Schema separates data into some fact tables, which hold all quantitative data about the business, and dimensions. Dim tables here. Dimensions have some attributes related to fact data. It looks really like a star, with dimension tables surrounding the central fact table. In our model, we have several fact tables which store data according to our business requirements. So we can say that our fact tables serve different Power BI reports, very roughly. For example, one fact table is for energy consumption data, another one for installation data, another one for invoices and costs, and so on. So we have also around 15 dimension tables storing information about installations, such as addresses, streets, what else? Zip codes, company hierarchy, contract information, temperature data, daytime, and so on. Dimension tables contain a relatively small number of rows. Fact tables store very large number of rows and continue to grow over time. That's where we have our billions, 1.4 for now, billion of rows, in fact, tables. And it's very important to consider possible performance application when designing the model. That's why we use star schema. First of all, not Snowflake. Snowflake schema has normalized dimension tables, and they take less space, but the queries are more complex and less performant. Then, dimension tables shouldn't have any duplicated data, of course, to ensure a fast process to fact data. All the keys should be integers, not strings. It's faster and takes less memory. Data should be pre-aggregated to the level we need in our reports. If, for example, we have data for every minute, but our business requirements is to show the data only on hourly basis, then pre-aggregate it together before adding to the model. You will save space and make your model more performant. And of course, we should provide only the data we need in our reports. No data for future use, no old data that are not used anymore in our reports. On top of our star schema, we have built our data cube. It's a multi-dimensional table which consists of pre-calculated values instead of calculating them on the fly, and it also boosts the performance. So, how then it works in Power BI? We store no data in Power BI. Each Power BI report generates a query that is sent to the Power BI model, and these queries are used to filter, group, and summarize model data. Well-designed model should provide tables for filtering and grouping and tables for summarization. And this design fits well with star schema principles. Dimension tables support filtering and grouping. Fact tables support summarization. Yes, let's go back to our diagram. Some data, for example, weather data, comes directly to the SQL database. And we also get data from smart meters in Germany every 15 minutes. We call it near real-time data. And we have a job which picks this data up every 15 minutes and transports. Event Hubs is a real-time data injection service. It can stream millions of events per second from any source. This Event Hub triggers Azure function, which transports our data to the same SQL database. And as we have all our data in one place in our SQL database, we can easily use it for analytics. And what we do in our project, we run a machine learning model to predict heat consumption, both for shorter periods using hourly consumption and temperature data, and also for 1 year using daily consumption. We have built the pipeline from the database to Azure Machine Learning Service. We export data per installation, first to Parquet files, then they go to blob storage, and then to machine learning services. We apply our models there, run predictions, then we transport the result back to SQL database, and there we can create our reports on top of it and visualize it for our customers. So, our model is called the Cube, is in Azure Analysis Services. Cube is a multidimensional structure that contains all the data. It's a single place where all related to application data is stored. This data is highly compressed, cached in memory, and our model can easily handle really massive amounts of data. Every time our data is updated in the SQL database, Logic App gives a signal to Azure Analysis Services. Hello, we've got new data, and it triggers cube refresh. And we can, of course, refresh the cube manually if needed. So we build model. We have our model data in Azure Analysis Services. Then we use our model data to create our reports in Power BI and then embed them in our web application. For some queries, we also use REST APIs to get the data from Azure Analysis Services, and we get the data really quick. So we got the data, build the model, created Power BI report. Here is the report. Let's look how to embed ready Power BI report in our web application using JavaScript. First of all, we need to include Power BI JavaScript library provided by Microsoft in our HTML page, and then add an HTML element with some ID. Then in our JavaScript file, we get the reference to our HTML element and embed the report into this element using embedded config. If you prefer to use TypeScript, you may want to use some other library, such as which is built on top of the official Microsoft Power BI client library. In our project, we use Angular, and Power BI reports can, of course, be embedded into React application or some other front-end application. There's no limits here. Some tips: keep tools and packages up to date. Always use the latest version of Power BI Desktop and the client library. Microsoft continuously releases additional updates, enhancements, so make sure to follow up from time to time. To improve the end-user performance, you can bootstrap the iframe before all required parameters are available. If you want to measure embedded performance, you may want to use loaded and rendered events provided by the library. So everything is straightforward until this point. What is config? Config consists of some properties. Filters and settings. Settings are used for localizations and to show and hide some report elements, such as navigation panel and so on. Filters are used to filter the data in Azure Analysis Services, for example, by installation or by date. This is really powerful mechanism to adapt your report to your page requirements. Permissions. If your users are not supposed to edit the embedded report, it's possible, but if they are not, most likely it's the case if you embed the report for your external users, then put read permission. Edit mode components will not be initialized and you will improve the performance. Type of token. There are two alternatives of embedding your reports: for internal users with Power BI Pro license and using Azure Active Directory authorization, and for external users. We will look more close into it. And the most important part, this part will let Power BI know which report are you going to embed and if you're allowed to see the report or not. Your report can have several pages shown as the tabs here below the report. It can be really handy in some cases. For example, we have multi-language support in our application. We have also different time resolutions for our data. We have data, aggregate data on yearly basis, monthly, daily, hour. And how we build it? We build all the reports for different time resolutions and also for different languages as different pages in one report. You can see in the tab below, they are called year English, for example, year Swedish, and so on. All the data is preloaded and pre-aggregated for the whole report. And then we can change language on the fly on runtime by simply going from one tab to another, or change our time resolution. When user selects different time resolution, we just show a different page in the report. And of course, we don't need to show this panel. We can just hide it. It will work perfectly well. A short live demo going to work perfectly as I recorded video. Here I select different time resolutions and switch between different pages in one report. You see how fast the data is aggregated and shown on hourly, daily, monthly, and yearly basis. So I don't re-render report. Everything is loaded, and I just change the view. And it works really, really quick. How we can filter our data in the view. JavaScript library has a powerful mechanism to filter the data. We have basic filter. It helps us to select the data from one specific dimensional table, filtered by a specific column. Here you see web companies table, and we filter by a column name. By doing this, we can select the data for different companies. We have also advanced filter, which can set the range in which the data will be shown. In our example, you see we want to show consumption data only for January 2019. Then I take the data from consumption history table and set the range. And several filters can be combined together for one report. We have an array of filters, as you can see in config. Another live demo. As I mentioned before, our customers have a complex hierarchy of data. They have parent company, subsidiary, installation. And our application, only with several clicks and filter, they can navigate from a summary over total consumption for the whole company and deep dive into installation level. And it happens also really, really fast because we just filter in one report. And this is really huge value for our customers. The heat consumption is really high cost for many of them, so they want to have full control over the data. So, all right. We have processed, cleaned our data, we prepared our data model, included the report into our web application and our HTML page, got all the parameters and settings in place. Now we need to select an appropriate embedding option. There are two types of embedding models available with Power BI, for organizations and for end customers. Everything depends on two things: how you license your Power BI users, and do you authorize your users with Azure Active Directory or not. When you embed the report for your organization, for your internal usage, you use so-called user owns data scenario. This is the simplest form. This scenario requires end user authentication to Power BI. So your users should have Power BI Pro licenses and permissions to the reports. Your users in this case can also access Power BI reports directly in Power BI desktop tool without web application. Another option is to embed the reports to your external customers. This model is called app owns data, scenario, and the end users don't need to have Power BI Pro license and can't access the reports directly. In this case, you can use your own authentication method other than Azure Active Directory. And access to Power BI is assigned to a master account or a service principal. This scenario is commonly used if you have external users accessing your application, and also if you use identity provider other than Azure Active Directory. Actually, when we worked with our pilot project, we redeveloped authentication strategy twice. First, we created our application using user owns data scenario, and then we understood that we were going to have a really lot of users. Then we introduced OpenID provider authentication solution and switched to application owns data scenario. And then we will look now for application owns data scenario. What do we need for this to embed the reports into our application? So first of all, we need to have Azure Active Directory tenant. Then we register our application with Azure Active Directory to allow our application access to the Power BI REST APIs. We need to specify permissions in Azure to Power BI resources. Then we need to create service account. This account is basically a standard user account available via Azure Active Directory. Then we need to get Power BI premium capacity, dedicated resources to our application, which can serve all our reports. And we also need to assign a Power BI Pro license to this service account. And all our Power BI reports should be placed within one workspace, and this service account must be admin of this workspace. And our application requires two different authentications. First of all, authentication to the web application, and then access to Power BI Pro and Azure Analysis Services. Let's quickly go through this flow. User starts a session with our application and redirected to the OpenID provider. OpenID provider authenticates, authorizes the user for a particular application instance. Then one-time use code is passed back to the web server, and web server passes the code and user credentials to the OpenID provider's token endpoint. OpenID provider validates the code, returns a token. Nothing new here, but this token has our custom claim, which we call access role, and used to ensure security of our application. Let's talk about security of our data. As we work with the customer data, we can't afford our data leaking somewhere, of course. We use security by design approach when working with our web applications in our company. And we get our custom claim access role from our identity provider. And in our model, we have a table with access roles, and they have one-to-many connection to customer IDs. It defines what companies this particular user has access to, and this user will be able to get only data belonging to his company, to his organization, nothing else. This access role is used for built-in functionality in Azure Analysis Services. It's called RowLevel Security. It restricts customers' data access to only data relevant to their company on a row level. All other rows will be just filtered out by Azure Analysis Services. There is no way to see others' data. These access restrictions are applied every time the data accessed is attempted. It makes this really reliable. So we have authenticated our user to the web application. Now we need to authenticate our application to Azure Active Directory using service account. This service account is stored in Azure Key Vault, so we need to retrieve credentials for this account using access token from Azure Managed Identities. After successful authentication, we get access code. Then our web application extracts access role claim from GVT token, requests a Power BI token using this claim, and the access code sent by Azure Active Directory. This access code is validated in Azure Active Directory, and after successful validation, Power BI sends back an unique embedded token to the web application. So we got the token, and this embedded token is used to create report request and retrieve the report data. And this is what was left in our embedded config. So this embedded config, which we use in our JavaScript, these parameters. So we have ready report embedded in our web application. It's done. Let's have a quick look into our processes. How often do we refresh our data in the model? How much time do we spend on it? We don't read data directly from our smart meters. We get a new data set every day from our internal SAP system. We have batch loading, which updates our historical data every night, 5 a.m. This process usually takes about 10-15 minutes, up to half an hour. Every day we perform incremental load, update only the data for the last 40 days, according to our business requirements. And of course, it would be very expensive and inefficient to update the whole data set. We use Databricks here. It's a really powerful tool. Uses parallel processing of the big data. So without it, it would take several hours to do a full load of data. Let's talk about costs of our solution. Both Azure Analysis Services and Azure Databricks are very powerful and well-performing services for big data pipelines, but they are also very expensive. SQL database, which we use as intermediate layer between data lake and analysis services, is also expensive. That's why we need to have full control over the costs. You can analyze costs in cost management, also build your own reports in Power BI using cost management APIs. So Databricks costs only when using, and in our case, we use it 15 up to half an hour, minutes a day. When we perform incremental load of data, then we stop the service and don't pay for it. Azure Analysis Services bills on an hourly base based on service tier and performance layer. No charges apply when we pause our instance, and we can reduce cost for Azure Analysis Services by just pausing it when we don't use it. We do it for our development and acceptance environment. Of course, we keep our production running all the time. But by pausing other environments during nights and weekends, we can save our bill, reduce our bill up to 60%. Then, one more point about the costs. Even if these services are expensive, all our 4 environments cost as much as half of one developer cost. Plus, if we use standard services managed by Microsoft, we don't need to spend money on managing infrastructure, testing, and so on. So we can really save costs by using these services. So let's wrap it up. Our need was to visualize large data sets for our end customers and to be able to quickly aggregate the data in different ways. What we have done, we got the data from different sources, gather it in data lake, processed using Databricks, and used SQL database as a temporary storage to bring the data to our model in Azure Analysis Services. We also built a pipeline to Azure Machine Learning Services to run our model and do predictions. Use Data Factory to orchestrate all this process. Then we used Power BI embedded to create reports and show them in the web application to our end users. What are the main benefits of our approach? First of all, it tremendously boosts user experience of our application. Our customers can get an overview over all their data in seconds. We can aggregate the data in any possible way. We can apply analytics on top of it to give customers insights on their data. We did some performance measurements. Our application now is up to 30 times faster than our previous traditional solution approach. It's also very scalable. Adding more users in the future will not affect our performance. We can also quickly adapt our application to the new requirements, A/B testing results, user surveys. New reports can be created and published just within a few clicks. No need to redeploy the whole application. We can quickly add new data sources to our model. Our customers can get new functionality really fast. Power BI reports can be seamlessly integrated with an existing application. It's easy to maintain, easy to do changes, no need to be a developer to create report. Built-in security ensures that the user can access only their own data. And as we use standard solutions provided by Microsoft, such as Power BI, Azure Analysis Services, Azure Databricks, and so on, they are maintained by Microsoft, not by us. So we could, by doing this, cut really development costs, maintenance costs, reduce testing efforts, and so on. So hope you enjoyed my presentation, got some new ideas. Thanks from me. Take this idea home, try it out. Maybe our approach can help you to solve some of your challenges with your data. I will be around in Slack channel after this presentation. Feel free to ask questions if you got any. I will be happy to answer. And then have a really great day and enjoy this amazing conference. Thank you.